Good morning, viewers, and welcome to my channel. This channel is created purposely to teach core physics, core chemistry, core mathematics, and elective mathematics. I want to use this opportunity to extend my warm greetings to all the above students, those far and those close. As they are enjoying their holidays, I encourage them to take their studies very seriously and also subscribe to my channel, learn more things so that when they come back to school, they will be abreast with the new things I'm teaching now. Yes, because the WASI exam, especially to the Form 3s, the WASI exams is just at the corner. So they must prepare adequately. As one of my friends said, he who rests, rests. So if you don't want to rest, then you shouldn't rest. Or when you rest, rest. So learn hard as you're in the house. So as I said earlier, this channel is created purposely to teach core physics, core chemistry, core mathematics, and then elective mathematics. I'm starting with core physics. So the topic I'm going to teach today is density. And density is under measurement. So this part of this subtopic pulls straight to many students because of the units and what have you. So I'm taking this topic so that I explain things to details for my students to understand. Now, when I talk about density simply means the mass per unit volume of a substance. Yes. So when I talk about mass, it's the amount of substance an object contains. So how heavy the object is. And also talk about volume, the space that object is occupying with the volume. Yes. Now, knowing mass and knowing volume, when you want to find the density, it is the mass divided by the volume. So if you look at the units, the unit of density is either kilogram per meter cube or gram per centimeter cube. The same as gram per cubic centimeter or centimeter cube. They are the same thing. Yes. So the reason why you have kilogram per meter cube over here, this kilogram per meter cube over here, is that sometimes the mass will be given, depending on the question, the mass will be given in kilogram, and then the volume will be in meter cube. So if you are asked to find the density, then you are going to maintain that you are going to leave your answer in kilogram per meter cube, depending on the unit given for both mass and volume. So if it is in kilogram, the mass is in kilogram, and the volume too is in meter cube, and you are not restricted to leave your answer in gram per centimeter cube, then you can leave your answer in this. And this one is the same as this. It's just that for this one, the division sign is between the kilogram and the meter cube. But for this one, it has been taken from the kilogram and the meter cube, and it has been brought here. So this one is correct, and this one is correct. Now, when your question is in gram per centimeter cube, the mass is in grams, and the volume G is in centimeter cube, you can leave your answer in this if there is no restriction. But if there's restriction that leave your answer in kilogram per meter cube, then you have to convert this gram to kilogram and convert this centimeter cube to meter cube. And we have a special conversion for that. And in the subsequent slides, we'll be looking at talking about that. There is a particular question for that, and we're going to solve them so that you understand. So this is the unit for density. So it is very, very important, especially when you're working physics or chemistry questions. Whichever answer you get, you must make sure you add the appropriate unit to it. Without the unit, it is wrong. Now, let's look at density. Density is equal to mass over volume. Yes. So if density is equal to mass over volume, the mass is capital M over V. Yes, the volume is V. Now density is represented by this slanted P, which is rho. So rho is equal to M over V. So you can have P is equal to M over V, where P is density, M is the mass, and V is the volume. So in exams, you can represent or you can write the formula for density, which is rho is equal to M over V. But you should indicate that this rho represents density, this M represents the mass, and this V represents the volume. Now, it is also important to take note of this. Yes. So if you are asked to find the density, this is the formula that will help you. This is the formula that will help you. Yes. So this is the formula. So rho is equal to m over v, as we stated over. Now, if you want to find the mass, you can make some small change of subject. So as we know that this is rho is equal to m over v. If you want to make mass the subject, just make some change of subject here. So you can get something like this. So considering this, realize that this is p, rho is equal to m over v. So if you want to make mass the subject, you multiply through by v. So we are going to get our rho, this our rho. That's nice. So our rho is going to be our rho times our v should be equal to our v times our capital M over our v. So this is how it will come. Then our v will cancel our v. So we get our mass to be equal to our rho times our volume. So this is how come we got our mass to be that. So it's just simple change of subject and you are good to go. Now, the third one too, you can make change of subject from here. So if m is equal to rho times v, you want to make volume the subject, then you can also make change of subject. So you can also do it like this. So seeing this, our m, which is equal to what our mass cos the density times the volume, we have something like that, something like this, which is equal to our rho times our volume. And you want to find volume, divide through by density. So here by density, then here by density, here too by density. Divide through like that. This one will cancel this, leaving our volume to be equal to our mass over our density. Our mass over our density. And this is what we are talking about. So we can also make change of subjects and you get that. So that is how it is done. So it is very simple. Now let's look at some conversions. Now, as I said earlier, sometimes you'll be given the question in gram per centimeter cube and you'll be asked to leave your answer in kilogram per meter cube. So these are the conversions that is going to help you. Now let's take some examples, solve them. Now first example, a piece of wood weighs 72 grams. What is its density if its volume is 20 cm cube? So the 72 gram is telling you that this is the mass. So this is the mass. The mass is 72 grams, and the volume stated over here is 20 cm cube. Now how do you do? The mass, you quote the formula. So you go back to quote the formula for density. The density is equal to mass over volume. Now our mass is 72 grams. Then our volume is what? 20 cm cube. Now you punch 72 over 20, you get 3.6. So you don't point together with the gram and centimeter, you just point the digits or the value there. So 72 over 20, you get 3.6. Now this is gram, then this is gram per, there is the per, the division sign, the centimeter cube. So this is what we get. So that will be the unit, the gram per the centimeter cube, 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 the gram per the centimeter cube. So that is that. So that's the unit for density after substituting. So that is the answer to the first question. Now let's try the second question too. A piece of iron has a volume of 15 centimeter cube and a mass of 27 grams. Calculate the density of the iron in A, gram per centimeter cube, B, kilogram per meter cube. So you see the mass is in grams and then the volume is centimeter cube. So the first one, which is gram per centimeter cube, you're not going to suffer. After quoting the formula, this is the formula. So after quoting the formula, yes, you are going to just substitute. Just because the mass is in grams and then the volume is in centimeter cube. So 27, so this is the mass of the iron, 27 gram over the volume, which is 15 centimeter. When you punch 27 divided by 15, you get 1.8. Then gram per, so this is the gram per, this is the division sign is here, per centimeter hot cube. And that is the answer to the first one. Now, if you want to find the second one, which is kilogram per meter cube, then it means that you have to use this conversion. This is the conversion you're going to use. So previously we said that when you want to convert from gram to centimeter cube, you multiply by 1,000 kilogram, or you multiply by 1,000. That is, when you want to convert from gram per centimeter cube to kilogram per meter cube, you multiply whatever value you have by 1,000. So now the answer we had for density after calculating for this one in gram per centimeter cube, we had 1.8. We had 1.8 gram per centimeter cube. So if you want to convert to kilogram per meter cube, that means that you are going to multiply that 1.8. Multiply that 1.8. I'm going to multiply that 1.8 by 1,000. So when I multiply 1.8 by 1.8 by 1,000 by 1,000. This is what you are going to get. Multiply it by 1,000. And get 1800. But the unit is in what? Kilogram per meter cube, or this. So this is how it is solved. So just multiply by that and you are good to go. So remember the conversion: 1 gram per centimeter cube, 1,000 kilogram per meter cube. So if you want to convert from this one to kilogram per meter cube, multiply by 1,000. Yes, that is that. So let's continue. Now let's look at our last example. Our last example, we are asked to find the mass. So a lump of gold has a density of 6 grams per centimeter cube and a volume of 24 centimeter cube. Calculate the mass of the gold. So we just state the formula. So the mass, this is the formula for it. So the mass is equal to what? The mass is equal to the density times the volume. Yes, so if density times the volume, then we are going to use that formula. So density times volume. So what is the density in the question? The density is what? 6 grams per centimeter cube, and the volume is what? 24 centimeter cube. So density is 6 grams, you substitute it there, times the volume 24 centimeter. Now this is how come we got the gram. So realize that this is 6 grams per centimeter cube. So 6 grams over centimeter cube, like something like this, over centimeter cube times our 24 centimeter cube. Our 24 centimeter cube. So when you multiply, realize that this one will cancel this one. Yes, leaving the grams there. So if the centimeter cube cancels centimeter cube, the grams will be there. So multiply 6 by 24, you get 144. Then the grams will be there. So please take note that the centimeter cube, gram per centimeter cube, is gram over centimeter cube. So when you are dividing like that, then it means that you can also cancel out. So that is that. Yes. I hope you enjoyed the lesson. I know that you work more examples, and this won't end. I'll bring more questions for you to solve. We have diverse questions. I'll bring different questions for you to try so that you become very, very, you understand the concept very, very well. Thanks for watching.